7.1, the inverse sine, cosine, and tangent functions. So we spend a good deal of time on graphing sines, cosines, and tangents and working with them a little bit. So now let's look what happens when we want to do something with the inverse of those. All these here are part of like our inverse introduction or inverse definitions or properties. So basically what it says here is that if you find the composite of the inverse and the regular, you should get x and vice versa. And the domain of the original is the range of the inverse, and the range of the inverse is the domain of, and the range of the original is the domain of the inverse, and these also go the other way around. And then there's symmetry, and if you want to solve for it, you literally swap your x's and your y's, and then you rewrite this in y terms only, and you get the inverse function. So let's look at the sine of x. So here's the picture of the sine of x. Okay. Now also keep in mind that for a function to have an inverse, so to have an inverse function, we need to have a one-to-one function for the original. And one way that you can look at that is the horizontal line test, and that's why this red line is there. And clearly the sine of x, and for that matter any of the trig functions, because they're all periodic, it's going to fail that definition because you always are going to get more than one of these points if you draw a horizontal line through the function. So what we are going to do then to find an inverse for the sine and the cosine and tangent is we're going to cheat. And with that I mean is and this is why they have different colors, we're going to cut this graph, the sine of x, and we're going to cut it right at a negative pi over 2 and pi over 2, because starting at a negative pi over 2 it's a negative 1, it goes all the way up to 0 and back, and then all the way up to 1, so all the y values that the sine takes on are present between a negative pi over 2 and pi over 2. So if we just limit the function to that domain, so if we limit the y equals sine of x to the domain of a negative pi over 2 to pi over 2, we will get the full range. And that's what this picture is trying to show you here. So here's this picture sort of lifted out. So if we have an inverse sine, so this is what it means. So it means that the inverse sine, which is usually written this way, is only defined if we use y equals sine of x with a domain of a negative pi over 2 to pi over 2. Good morning to you. Okay, so that is very important to keep in mind, because that limits your inverse sine as well. Because now let's look at domain and range a little bit. So we're going to have to say that this is the domain for the sine of x, and then this is the range for the sine of x, and the range is full, right? The domain is limited, but it has a full range. But that means that the range for the inverse is from a negative, the domain for the inverse is from a negative 1 to 1, which is okay. That's what we want. We want to be able to put anything in an inverse, but you will only get angles between a negative pi over 2 and pi over 2 out of it. Okay, so these are the only possible answers. So you could never have this. You could never have the sine negative 1 of some value and then say, well, that was 7 pi over 8. It's impossible. 7 pi over 8 is greater than pi over 2. So this is not an answer that is possible. All right. So let's look at finding exact values of an inverse function, and we're going to do, well, I guess I have without the calculator first, and I think your notes it's backwards. I'm not sure how that happened, but alright, we'll do it this way. So the inverse sine is supposed to give you an angle, right? Well, so for me to solve these, because I don't have these unit circle values all memorized, I do it this way. I say, well, then that's the angle that we're looking for. That means that the sine of the angle is supposed to be the square root of 3 over 2. Well, that's your hypotenuse. Sorry, that's not your hypotenuse. that is the sine, that's the opposite side, and then that's the hypotenuse. And then I look, so if that's the square root of 3 over 2, that's positive, so I know, keep in mind that this only goes from a negative pi over 2 to pi over 2, and I know the sine's positive if it's between 0 and pi over 2. So if I draw this picture, I know I'm in quadrant 1. So opposite side is the square root of 3, and this is the 2. That means I have this triangle, obviously that's 1. So the angle that I'm looking at is a 60-degree angle, and then that would be the answer. The answer here is pi over 3. The same thing sort of over here. So this is the angle that, or this value will give me an angle. So that means that the sine of the angle should be a negative square root of 2 over 2. So I also know that you can rewrite this way, so that one I'm a little more familiar with. So that means that if I look at the domain, so that means that if I look at, actually I should say the range of what the inverse is going to give me, it gives me values between a negative pi over 2 and pi over 2. Well, the sine is negative if I'm between 0 and a negative pi over 2, so because it's the y value. So I need to be in quadrant number 4. So then, again, that's opposite, right? There is opposite, so that's the one that's actually down, and then the square root of 2 would be here. So I have a 45-degree triangle that is negative, right? So that is a negative pi over 4. Okay? So that's it. Okay. If you're given a calculator, then you can clearly just plug this in. Now, you need to watch out and make sure that when you use your calculator for here, that you will that you have this set in radians. So in the calculator you need to be in radians. Okay, and I used to have a graphing calculator I could show you, but I don't right now. But we can. Here's my email. So let's look at scientific calculators. I should be able to come up with one. And so, do we have an inverse sine or a sine on here? So it looks to be right there, right? So the inverse sine of, what did we say, 3 over 5, 3 divided by 5, and then we get an answer, and it says it's 0.64. Now how do you know if it's in radians or not? Well, here it says radians, and now it's and so if I clicked on it, it disappeared. So now if I do it, then it looks to be in degrees next. So let's start again. So the inverse sine of 3 over 5. And on this one, I'm getting 36. And that shouldn't make much sense, right? Because 36.8, that sounds, or that even feels like a degree. Because if that was radians, that would be 36.86 radians. And the inverse sine isn't supposed to give you anything back between, other than between a negative pi over 2 and pi over 2, and a negative, pi is like 3-ish, so 3 divided by 2, the value should be between a negative 1.5 and a positive 1.5, so that's clearly it, not it. Okay, so look, this says if you use the inverse sine, you're going to get a radian answer, and that's what you wanted. Okay, alright, so back to the notes, if I can. So this one, it said 0.64 if I rounded it, and again that's in radians. And this one says, this one would give you a negative 0.73, and again that would be in radians. You don't have to say it, but you know, if it's a number without pi, we often include radians. Okay. Okay. Then the last thing that I really want to point out is that I did mention it, is that the inverse sine will give you a rotation as an answer, right? So I think this is very important, that you start writing these problems and using an angle here and rewriting it and then solving it. It will save you a lot of headaches down the line when we make this stuff more complicated. Okay. Alright, then here is a little chunk that deals with some of the properties. So this says, you know, the inverse, if you take the inverse of the original, you should get x back and vice versa. Okay. Notice that here, that if you take the inverse sine of something that is, if you take the sine first and then take the inverse sine, then the x is an angle. And this is one reason why I said this is a nice, it's nice to think of the inverse sine as an angle. So if I give you this, I know that I get a rotation back out of this, so then I know I need to be between a negative pi over 2 and pi over 2. That helps me. So it also means that the sine of x, okay, that one gives you a value, right? So if I start with the sine of x, then I know that the answer, okay, is a value between a negative 1 and 1. So this is the normal version, so the theta actually would be here, and the value would be here. Okay, so let's check this. So if you take the sine of pi over 2 and then take the inverse, you should be back at pi over 2. Well, that works great. Yeah, it's pretty straightforward. If you take the sine of 3 pi over 5 and then the inverse, you should be back at 3 pi over 5. Except if you look at 3 pi over 5, that's more than pi over 2. 3 pi over 5 would be here, wouldn't it? Okay, so then you have to do the following. So I'm actually interested in this little angle here. Well, that angle there, if this is pi, that little angle there, that's 2 pi over 5. So now I have two choices. So the answer here is either going to be 2 pi over 5 or negative 2 pi over 5, and it depends on the y value here. In quadrant 2, your y is still positive. So the inverse sine here is not going to give you 3 pi over 5 back, because 3 pi divided by 5 is greater than pi over 2. Right? So it cannot give me this back. So it needs to give me an angle back that will give me the same y value. So I want 2 pi over 5, because if I rotate 2 pi over 5 this way, I would get, and sorry that the picture's so messy, but I would get the same y value over here. So the answer is 2 pi over 5. So this is sort of weird, because that's not usually what happens when you find a function and then take the inverse, because it should have undone it. Okay, sort of the same ideas here. I think these are a little easier. So the inverse sine of negative 0.4, and you take the sine of that, you should get a negative 0.4 back. That is completely possible, right? Because the sine is always between a negative 1 and 1. Well, because of that, that's a problem. The sine, you cannot say that this answer is going to be a negative 1.2, because the sine will only give you values between a negative 1 and 1. So it is impossible to do this. Okay? So that's not possible, so you would just say not possible. Okay, what else do we got? Well, we obviously have inverse cosines and inverse tangents as well, so I'm not going to go through the whole spiel with this, other than to say, well, we need to make sure that we only look at this as the original only for a one-to-one function, and so you're going to have to memorize some of this stuff. So the cosine, we're going to limit it from 0 to pi, because at 0 the cosine is 1, right? And then we get a negative 1 once we get to pi. Okay, so the cosine, the inverse cosine, only returns rotations between 0 and pi. Okay, and from 0 to pi over 2, it will be positive. And from pi over 2 to pi, your cosine will be negative, right? Yeah, look at, if you think of it as the unit circle, so this is where all this comes from. X here is positive, x here is negative, and there's pi over 2. So the inverse cosine initially gives you positives from 0 to pi over 2, and then the negatives come when you are between pi over 2 and pi. Now the tangent's actually the easier of the ones here, because the tangent is a one-to-one function. The original function is one-to-one if you only go from one asymptote to the other asymptotes. Okay, so that one's a little bit easier, I think. Okay, so let's find the exact value of. So I'm going to do the same thing here. I'm going to say that's theta, so that means that the cosine of theta should give me a negative square root of 2 over 2, which I would write it this way. I know it's a negative, and then the cosine would be negative, so this one is between 0 and pi, so the angle should be between 0 and pi, so I need to be over here. I need to be over on this side. I know that's a 45-degree angle, because that would be negative 1, and that would be the square root of 2, and so that's pi over 4-ish, and then how many pi over 4s do I need? So 1 would get me here, 2 would get me here. I need 3 pi over 4 to get in quadrant number 2. Okay. That's a positive cosine, so I should be between 0 and pi over 2. So the picture puts me in quadrant 1. Okay, so the adjacent side is 1, hypotenuse is 2. That put the square root of 3 over here. That's a 60-degree angle. So this is pi over 3. Okay. Next one, tangent. So this returns an angle. So it means that the tangent of the angle should be, and this is a negative 1 over the square root of 3 as well. So tangent would be negative if I'm in quadrants. So maybe I didn't really point this out, but okay, you need to be between a negative pi over 2 and pi over 2. For the tangent to be negative, then you need to be in quadrant 4, right? Because that's where one of these sines or cosines is negative. So let's see, that's opposite over adjacent, right? So the opposite side is the negative 1, and the adjacent side is the square root of 3. So we get something that looks like this. So that's actually a 30-degree angle, okay, except it is a negative 30 degrees, so that is a negative pi over 6. And the tangent, the inverse tangent of a negative 1 gives you an angle. So the tangent of the angle should be a negative 1. Alright, the negative 1, think of that as a negative 1 over 1. Again, since it's negative, you're in this quadrant. With this one 1, that one negative 1. So you're at 45 degrees with a negative. So it's a negative pi over 4. So there are your answers. Okay, next part. It's a bit of a long lecture because I had to get into the inverse properties a little bit. So you can also do this the same, original and then the inverse and vice versa for cosines and tangents. So let's see what happens over here. So the inverse cosine, that's supposed to give me an angle, then that means I need to be between 0 and pi, right? So 2 pi over 3, that is good. 2 pi over 3 between 0 and pi. Okay, if that had been 4 pi over 3, I would have to make a little picture and put it back into a 0 to pi answer. The inverse cosine of 0.6, then take the cosine. So if this works, it would be 0.6, which is an answer that can come out of the cosine. Okay. The inverse cosine of 1.8, and then take the cosine, I should get 1.8 back. But 1.8 is impossible to get. This is impossible. There isn't an angle that would give you a cosine of 1.8, so this one is not possible. Okay. By the way, the tangents should always work, right? Because the tangents, you get any value you want out of the original, so you can put whatever you want into the inverse tangent. Okay? Alright, so inverse tangent of 1 over the square root of 3 and then the tangent, so this should work. Okay, it's a positive anyway, so that's just 1 over the square root of 3. Here the inverse tangent and then the tangent of pi over 7 first. So if I find an inverse, then this is supposed to represent an angle. So that angle that is being returned better be between a negative pi over 2 and pi over 2, and pi over 7 is less than pi over 2, so pi over 7 works. I probably didn't give myself enough room here, but it's sort of the same idea. You need to give an answer between a negative pi over 2 and pi over 2, and 5 pi over 3 is greater than pi over 2. So let's look at the tangent of 5 pi over 3, where that actually would put you. So 5 pi over 3 would be, so 3 pi over 3 would be here, 4 pi over 3 would be here, 5 pi over 3 would be here, right? This is 5 pi over 3. Okay, we are in quadrant 4, so the tangent is negative. So this is the rotation I have this way. So I'm actually, this answer is going to be the angle from here to here. Okay, if that's 5 pi over 3, then that's pi over 3, that is left. But it is in negative direction, so your final answer is it's a negative pi over 3. Okay? Hopefully I did that right. Okay, last couple ones. So find the inverse function given, okay, and then state the domain of f and the inverse of f. So this is what's given to us, right? And we're just supposed to swap x's and y's. So that's a negative 3, the cosine of y plus 2. Then we have to solve this for y. So this is x minus 2 is equal to a negative 3 times the cosine of y. That takes care of that one. Then divide by a negative 3. So the cosine of y is x minus 2 divided by a negative 3. Take the inverse, because if you take the inverse, then you just get y out of that. And then that will be the inverse function that we're working with. Right? Okay. State the domain of the original function. So what's the domain of the original function? Well, the domain of the original function, so for the cosine to have an inverse, the domain needs to be between, what, 0 and pi, right? So we need to have a domain that's between 0 and pi. So this is for the original, which is f of x. And the range, well, the cosine only gives you values between a -1 and 1. Okay? So it's time to switch the color here for once. Alright. So now we're going to go to the inverse. So we can literally swap domain and ranges. So the domain of the inverse will be a -1 to 1, and then the range for the inverse is from 0 to pi. Okay? Hopefully you're thinking no, because this is actually wrong, isn't it? These two are going to be wrong. So let's look at the range here. Okay, this is actually the range of the cosine of x, and that's what I said, is from a -1 to 1, right? But there are some transformations over here. So what does the -3 do? Well, the -3 changes that cosine, so to make it a -3 cosine of x, you would have been between a -3 and 3. And then the 2 adds 2 to all the y values. So 2 plus a -3 cosine of x would add a 2 to this. So that's a -1 to 5. So actually that is the range of the original function. The original function goes from a -1 to 5. That means that the domain for the inverse is going to be from a -1 to 5. So those are the values that you need to plug in there. Okay? I have it right in my notes, and I did catch it without looking at it, but be really, really careful with that. So take a good look at this function, and this is one reason we graphed so many. Take a good look at your original function and try to picture what that thing would look like. So it's shifted up to, and the amplitude was much, much higher. So a quick sketch that I would have given you, wow, it's shifted up to, and then the amplitude is much, much higher. So it would have looked like this. It would have had much more spread. Alright, last part. Solve the equation. Alright, so initially just treat things like numbers, because a lot of these things are just numbers. And then that's 1 inverse tangent minus 5 inverse tangent. So 1 minus 5, that's a -4 times the tangent, the inverse tangent of x. And on this side, 2 pi over 3 plus pi over 3 is 3 pi over 3, so that's just pi. So the inverse tangent of x is actually supposed to be pi divided by 4 with a negative. Right? So that means that the tangent of a -pi over 4 is the x that I'm looking for. So I am rewriting this again, and then I'm going to look for this one. So what's the tangent of a -pi over 4? Well, -pi over 4 would be here, right? And I know that that's 1, and that's a -1 because it's 45. So the answer here is, and then that would be the square root of 2. So the answer is x is a -1 over 1, which is a -1. Okay, thank you.